Okay, let's begin our meeting today. Seong, Alan, Richard, Liam. Okay. Uh, let's start. Um, hey, Richard, what rotation are you on?
I'm not on a rotation currently, so I have some time.
Oh, okay. Let's do people in Korea first. Alan, do you have any update?
Uh, yes, Dr. Chae. So I I can actually show you the I guess manuscript at the current form right now. Um, would you like to read through the entire thing right now, or
Show me what you edited. I
so I've been I've been editing in portions about either the limitations as well as the prediction of the ICI response. Yes, and the limitations.
So for the whole group, show me the title and abstract.
The title role of AI in digital pathology in immuno-oncology. The abstract is like this.
Hmm. Okay, so it's going to talk about diagnosis, immune biomarkers, and prediction of immune checkpoint inhibitor response. Okay, now show me, go back to the second.
Yeah, so this is the first edition that I had added in.
So what is the subheading for this?
This is the subheading is prediction of the ICI response.
Okay, what is Pepsi?
Actually, is the just the author of the article that I looked up, and it's just a kind of just a bookmark kind of what I put in for now.
Hmm. Hmm. The density and proximity of leg 3 positive TIL to
Sure.
MH2.
Yes,
Is it MH2 expressing tumor cells?
it should be expressing. I remember it as expressing, but I'll confirm
Yeah,
that.
find out what the paper actually used.
Mhm.
They found that there was a greater proximity and density in tumor cells, allow
Yes, when
inhibition of the anti-tumor immunity. Oh, I don't think it makes sense.
uh,
That sentence to me.
mhm.
So what was the inhibition of anti-tumor immunity? What does that mean? This is talking about response to immune checkpoint inhibitors. So
Yes,
in bladder cancer patient,
mhm.
gastric cancer patient, did they receive ICI? And what does inhibition of anti-immunity mean? Does it mean increase in survival, increase in progression-free survival, increase in overall response rate? And how do you measure how do what was the correlation? Was it a hazard ratio correlation? What is the outcome? It's so vague, and I don't know if this is a mouse experiment versus a patient data. Everything described here is so vague. Do you understand my
Okay.
point?
Yeah. Yes.
Just by reading
Uh,
it, I don't understand anything about the data. So
all right.
make sure that the readers understand what the study looked at and what is the
Mhm.
exact outcome and how do
Mhm.
you derive a conclusion from the data. It has to be a stepwise.
Okay.
Okay. All right.
Okay. Yeah. I'll need some more information about that part. And then the next part is prediction of toxicities, and then it explores cancer biology. Um,
So what is DNN?
DNN, I believe it was its deep learning neural network. Um, would need to,
But was it used before?
not in the current manuscript, no, but in the in the article that I'd been reading had uh, it mentioned it was that.
Yeah. So this is writing 101. Like always use the
Mhm.
acronym that you already described in the former method or introduction, wherever.
Yes.
Um, what about CNN? Was it used before or just here?
CNN was also used as so DNN was deep neural networks and CNN was convolutional neural networks.
Hmm. And such language is not routinely used in medical journals, maybe used in
Hmm.
AI journals. So you
Hmm.
do have to um, write it out sometimes or explain what it is.
Yep.
Um, so here I don't know the difference between CNN and DNN, why they use two different things. So
Hmm.
there's a lot of questions here. So you have to be able to explain what
Hmm.
they are, why they used it, and when you say predict, what did you actually find? Um, they must have used some sort of correlation outcome, numbers and
Hmm.
p-values. Uh,
Hmm.
better to cite those. Because this is still the main text, right? It's not a
Hmm.
abstract or anything.
Hmm.
Okay, move on.
Okay, so overall, just again, it's a little bit too vague. Um, and then the next part, we talk about the limitations about the AI. Not yes. So,
Mm, so what what are the reference articles? How did you come up with these ideas?
Uh, I basically tried to just summarize what the two articles had actually mentioned as what they were the limitations for their I guess it's the overall problems with the AI pathology right now. Um, and so yes, I both of these two articles actually kind of mention in a similar vein about just how there's no current standard for AI pathology and it's still an improvement. So uh, that is actually what I was trying to say. But
Hmm. Yeah. Can you go up?
yes,
So co-working space, AI and physician. Go down. So this is not something to be under that subheading. It's a unique,
okay,
right?
maybe I should put it into a separate one. But the current subheadings that I have for I guess the limitations about the AI pathology had been that currently set as like this, and so it's data regulations. Wait, no more. Doesn't entirely fit, and I wasn't really sure if I should make a new subheading to kind of fit into.
So challenges, current landscape, current challenges and future
Mhm.
direction, data, regulation, explainable AI, multiplexed integration with other data. So what you said is what would be the subheading? Because it talks about many things, many points.
E- yes, so what I talked about was more of, I guess, the overall limitations about current AI pathology in the current form. Um, yes, I realize it doesn't really fit into all of the other subheadings. Uh, I thought it might actually have been a
So
good
what is
point to
the
put in.
subheading? You have to put a subheading because it doesn't belong to
I,
any one of it.
okay, I would I would have to think it would just be some kind of an over-encompassing subheading, maybe just like the just overall problems with AI pathology currently, because yeah, it might I guess it would be more of the first subheading, and then it can start talking about the data and then regulations related to that. Um,
when you write a manuscript, it has to be simplified in your mind, and then it has to come from you. You cannot copy paste or just rephrase in here and there, use good, sentences that are fancy here and there, and just, that's not writing. You have to absorb everything, make it yours, and simplify, and first persuade yourself, yes, this is the main problem, and then you write it. You understand? I don't see that
Yes.
if it looks like somebody else's words here and there, rephrased into one paragraph. So think hard. This is still about writing. I don't think there's like one idea here. What's the problem with AI? In one word, what is it? Value interpretation result? Like, there are fancy words used, but do you know what it means? I don't understand what it means. So you have to understand all the papers first and make it yours, and then present to the people and make sure it reads very easy and understandable.
Okay.
So I just because what's written in the above subheadings are pretty clear. The data has to be good. There has to be interaction with physician. The regulatory approval has to be there.
Right.
And it's just not H&E slide alone. Multiplex IF immunofluorescence has to be integrated. So there are points, but in here, so many things are mentioned that I don't see the value of it. So, I'll give you a chance to make that a separate page table, a paragraph with subheading, to make it just like a general comment. I mean, it's just still confusing to me. Okay.
Okay. Yeah.
All right. Move on.
Yes. And so I'll be making those changes, and then what I remember, he had suggested that it would be going into the GITC, I believe. And so they have a
So,
word.
so when we wrote this was like 2 years ago, right?
Yes, I believe so. It
So in
started
2
2 years ago.
years, I do think there are many AI model. There are so many companies, so many not just Lunit, but Path AI. There's
Yes.
many different companies. So make sure you cite all of those, not miss any single one. And even our own TLS abstracts, you can get that from Dr. Isol Kim. We use AI to measure tertiary lymphoid structure, and we correlated that with the response to immune checkpoint inhibitors. So you should cite our own abstracts.
Okay.
Dr. Isol Kim has all the information. So the real point of this review is make sure this is current and up to date and not miss any single relevant paper. That's what the readers want when they read a review article. They want to know the complete picture of what's going on.
Right.
So I want to make sure
yes.
you're complete in that aspect.
Yes. I guess in thinking about in the same. Sorry, Dr. Chae, did you say something?
No, go
Yeah. So I was concerned about the word count. I If it was JITC, it has a word count of 5,000, and right now, if I add in changes, I think I would have about maybe 600 more words that I could add in. And I was actually just going to ask because I realized a lot of the newer articles really talk more about it starts off talking about the microenvironment itself, and then it leads on into either immune biomarkers, or ICR response and things like that. And I was wondering if I should actually just maybe add in a separate section about just the tumor microenvironment. To begin the, I guess, the main portion of the writing, and then start talking about the biomarkers and ICIs.
I think it can still be under immune biomarkers. So immune biomarkers representing, describing immune microenvironment could be a subheading because immune biomarkers could be PD-L1, TMB, any others, but microenvironment could be one. And some people might be measuring immune cells there, you know.
Hmm. Okay, I guess I was kind of misunderstanding whether or not biomarkers would be the bigger heading or whether a tumor microenvironment would be the bigger heading. But
Now, biomarker is the bigger concept. Under that, there's a microenvironment.
okay, right. Okay, I'll have to try to add in what I can within about 500 words, I think, or 500 to 600
So,
words.
so things like, the regulations, challenge future directions, you can cut down 50% of what's already written here too. So when you cut things down,
Hmm.
preserve the original writing because if you go to a different journal, you can be more unlimited.
Hmm.
But the focus is really the number two, not number three. Okay, number three is there to just show that we are poised. There's equipoise. There's some debates here and there. Number
Hmm.
two is where we really show the evidence, not miss anything. Okay.
Okay.
Same thing, you can cut down introduction, you can cut down yeah, but I would say anything in the number two has to be very concrete, detailed. Yeah.
Okay. Okay then. Yeah, I'll have to make those kind of changes.
Okay. Not
Yeah,
easy. This is a very sophisticated writing and very important field. So
it's it's a lot of. I realize there's a lot of different projects, or I mean, like a lot of articles related to it, and but yeah, I should be able to get this done at least within the week. So
yes, yes. So maybe this is March. Um, let's get the whole thing submitted in next 4 weeks.
yes, 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 I'll get that done. Yes,
So
within a month. Yeah.
just like you're doing, if you have any questions, um, just keep asking. This is the time to learn,
Hmm.
brainstorm together,
Hmm.
and if you have a question about the article, is this a meaningful thing? Show us the actual article you reviewed.
Hmm.
We'll learn from those recent publications.
Right. Yes.
Okay,
Okay.
all right,
Yeah.
good job. Keep working. We'll move on. Also, who's Taeyong, you're in Korea. Any updates on your projects?
Yes, I'm here to check with the posters that's supposed to be submitted soon for the AACR. So I'll share my PowerPoint first with the mixed response. Can you see the
Yeah.
let's start from here.
Background, method, 177. Hmm. Okay.
Mm, For the results, I put
Wait.
the
For the method, for the poster, you don't have to explain twice because In the method, there's
Okay.
a text and then there's a table, right?
Right. Okay, I'll just get rid of this one.
No, I actually like that better.
Oh, okay. Then I think it'll be
'Cause it's
better.
the
I
same,
think it'll be
right?
better this one. Yeah, it's the same thing, but I just wanted to.
Yeah,
I'll try to reorganize this after
yeah, so
everything
make,
else is
yeah,
set.
okay.
And
So,
for the results,
so for the group, can you read the title again?
oh, it's clinical implications of mixed response on prognosis of NSCLC patients treated with immunotherapy.
Right. So mixed response, for those of you who are in my clinic, often see in a CT scan after the first treatment, one lesion gets larger, one lesion gets smaller. How do you best describe it, and how do you correlate that with differential outcome response to therapies? So here, responder, non-responder, there's a big difference. This is based on, according to the definition of response A. So where is mixed response in this graph, figure 2?
This is the Kaplan-Meier graph of responder and non-responder. So the responder is the red line here and here.
What do you mean responder?
Responder means the patient group that had a positive response for the mixed response definition that we had, that the patient would have both lesions that increased and decreased at the same time. And the one that had a significant statistical response was the patients that had definition A of mixed response, which we set it 5 millimeter of standard as a definition of increase or decrease, as you can see. And for mixed response B, it was the cutoff was only 1 millimeters, and the results for these did not have any significant values. So I just put it the only significant Kaplan-Meier graph here.
So who are non-responders?
Non-responders are patients, according to mixed response A, either patients who started with more than 2 lesions, but they did not have 5 millimeters of increase and 5 millimeters of decrease at the same time. So those are the non-responders.
So I think the graph is misleading and it needs to be changed, because when you put responder, people will think
Mhm.
they are responders by, PR or CR by RECIST.
I see.
And the non-responders, they think they are either PD alone or PD plus SD. That's how people think. So you cannot use those words here. And the
Mhm.
second point is that when you say not, well, so the responder should be rephrased as mixed responder. And
I see.
non-responder, I don't think it makes sense, because in non-responder, there are CR, PR,
Mhm.
PD all
Right.
mixed there. So
Mhm.
in my mind, it doesn't make any sense. So I
I see.
would have the true responder, who are CRPRs, as a
Mhm.
responder, and then you have non-responder as just well, when you say non-responder, there's stable disease people there. So
Um, Well, I think I could have made it more clear, but I should have said it earlier that this group only is restricted to patient groups who had overall survival response of PD based on IR-RECIST. And from that population, I tried to group that population into mixed response responder and mixed response non-responder. So these responders is not related to those stable disease or whatsoever.
So, but when you say PD,
Mhm.
so everyone initial, so the PD. So is the best response PD or the first scan PD?
It was best response.
Best response PD. Okay. If they're PD, so you're separating by mixed response versus non-mixed response, which
Mhm.
are all progressors. Every lesion is likely increasing in size, right?
Yes, true.
But how come they do much better if they all progress?
Oh, so this is comparing the months, follow-up period, months of progression-free survival. And so MOS and MPFS was compared within the group.
So this figure 2 that is according to table 2, the
Mhm.
last row, right?
Yes,
PD
this
IR resist. So 11.8 versus 4.8.
Mhm.
PFS 5.5 versus 1.4.
Yes.
So this is shown in the figure 2, correct?
Yes.
So first of all, you cannot use the word non-responder responder. It's mixed response versus
Mhm.
non-mixed response
Got it.
in every paper. Second, here, mixed response in PR doing worse. SD is doing, OS is better, but PFS is worse. And then in PD group, mixed responder with by resist the same. PFS is not significantly different. But in iResist PD group, mixed responder does worse. And it's just 39 patients.
Mhm.
And it's interesting, it only happens in IR resist, not resist. So, it's counterintuitive. You would think that all lesions, every lesion getting larger, those
Mhm.
people will do worse in general,
Right.
compared to some lesions showing shrinkage. But in this graph, both OSPFS shows that no mixed response did worse.
Mhm.
So I wonder why. I wonder if this is all random effect or if
Mhm.
there's any explanation. Because common sense tells me I don't understand this phenomenon, if it is really true.
Mhm.
What I'm thinking is this is 39 patients, but if this is 3,900 patients, I don't think we would see this. This is probably a random effect in my mind.
Mhm.
So, I know this is, yeah, just, I don't know, just make sure there is no statistical error that happened when
Mhm.
when doing the analysis. And maybe it's just the IR resist thing.
Mhm.
And maybe think about the PD group is different, 45 versus 39. Maybe that difference, the 6 patient difference, they might be outliers that would skew the data like this. There may be a reason by IR resist that, the figure 2 results happened.
Mhm.
Yeah, I'm just having trouble understanding. Uh, But in the figure 2, I would say of response PD. So survival of patients with best response being PD.
Mhm.
That's a better title. Survival of patients with best response being PD
Oh.
based on resist. And then that was by mixed response. By the presence or absence of by the presence of mixed response, according to the definition. So
Okay.
give it, yeah, by. So when you
I.
by the presence of mixed response.
I see.
So when you describe a graph, what is it
Mhm.
measuring? What is the population? If you have 2 graph, what is your criteria of separating the curve? That's by. So make sure all your graph titles are following this format, okay?
Mhm.
So table 2 changed
Mhm.
wording, same way, the responder.
Yes.
Go down to table 3.
So I was just trying to show mixed response A and mixed response B. I'll change this to.
So here, see, in PD, mixed response, OS doing worse. PR, mixed response, is doing worse for sure. Okay. Go in table 2, if you look at PR resist, 42 patient progression-free survival, mixed responder is a lot longer.
Yeah. When submitting the abstract, I remember having the same conversation. I looked through it, but couldn't find it. But I can still look again for the reasons.
Mm. So in PR, when you write this as a manuscript, you're gonna have to describe or reason why this happened. So mixed response in PR group means that the sum of the largest diameter was less than 30% or more, which means even if there are some lesions that grew in size, rendering itself to be a mixed response lesion, we think maybe that growth is a pseudo progression where there are many lymphocytes that are being infiltrated around the tumor. And maybe those people live longer. So we can consider that. Um, that's for the PR group. But for the PD group, how do you explain mixed responder doing worse? Again, that could be random effect, but a lesion that got smaller by 1 millimeter, doesn't make much difference, but by 5 millimeter, it got smaller. But most of the other lesions got larger. That's why they eventually belong to PD group, even if there's some response. So all lesions getting larger versus some lesion getting smaller. And how do you explain this? So I don't think any immunology phenomena would explain this. I can only say that, mixed responder, if they belong to PD group, the main clone or the largest tumor burden clone, if they are increasing in some more than 20% by the RECIST criteria, then you are saying, despite one or two lesion getting smaller, the other just two belong to that PD group. The sum of the largest diameter should still be 20%, it's 20% or above, right? So that means that remaining progressing tumor has to be increasing at a faster rate than regular PDs to account for the response in other lesions. So we can argue that mixed response PDs may be as bad as all lesion progressing PDs or PDs without mixed response. So you can argue that it could be equally as bad for that reason that I just explained. But I don't know if they can be worse than all lesion progressing PDs. It's still, biologically challenging to give any plausible explanation for it. But it is what it is. We report what we find. Just make sure there's no error. And when you report it, just report, this is what we saw. This is kind of puzzling. And the point is, I think the mixed response is bad. Wherever it is, it's bad. Yeah. Okay, conclusion. So did not impact the prognosis.
Mhm.
Is it true?
Um,
What graph shows that?
mm, I think it'll be hard to say like did not or did because the groups are small and I think I'll need to come up with a different sentence just to have a more have a sentence that's more just combined regarding this result that showed significance.
Hmm. So cohort A is the 5 mm, right?
Yes.
So if you just look at cohort A and stable disease, that's not significant.
Mhm.
So that's something we are interested. It's stable disease, but one lesion showing progression, one lesion not showing progression, but some of the diameter is still within that stable disease boundary.
Mhm.
Are they different or not different? It looks like they're not different.
Mhm.
Uh, oh, and something that I would also do is for table 2 and 3, I would combine CR and PR.
Oh, but oh,
So it's CR/PR and just add those 3 patients.
but I can't recall perfectly right now, but there was something about CR that it couldn't be statistically in like made, but I can check and do yeah, I can try
Yeah.
it.
Tell me when you find out. Yeah. Um, the other thing is, let's say you have resist 4 categories, and then you have p-value,
Mhm.
because you're looking at 4 different groups.
Mhm.
It's a subgroup analysis. And you're using resist IR resist. So you could argue. So read about statistics textbook about the Bonferroni P. When you do subgroup analysis, you divide the p-value by the number of subgroup analysis you do. So the p-value cutoff is not going to be 0.05, smaller. So read about it and see if that can be applied. That way you can disregard the 0.01, 0.02 p-values in the IRSS PD. So read
I'll try
about it.
that.
And that way you can still uphold the first sentence in your conclusion. Because I don't think that's a message we want to. What I'm saying is the figure 2 is not our punchline.
Okay.
Because this is sending a message, it's, even in all PD group, mixed response does poorly. But this, you can't replicate it when you do, this is only IR versus, so. I would say if you combine stable disease and progression, then you won't see this pattern. Uh, Yeah. Anyway, go down to the conclusion. Both A and B did not demonstrate improved prognosis. So the mixed response didn't show any improvement. Further. Okay. Those are okay.
I'll
Yeah,
check with.
challenging. So think about all these, keep reading, and when you make, so are you also writing manuscript?
No, not yet.
Who's in charge of writing the manuscript for this?
Um, I think this project is currently just run by me now, so
Mm.
I guess I should start.
Yeah, because take you still,
Yeah.
and yeah, I don't think anyone else is doing it, and you'll be back soon. So,
Okay.
yeah, I think this one deserves to be written up as a manuscript.
Mm.
We have a separate Dart paper. Liam, who's writing the Dart mixed response? Do you know?
I do not.
Hmm. Okay. So there's a mixed response Dart paper. Mm, oh. I think it might be a good project. Because Taeyong, you have not been involved with the Dart, right? So
I think I was in one of the meetings. Is it with the like comparing the mixed response within trials or something? I can't remember.
yeah, so I wanna pair up Taeyong and maybe Dr. Seungwon. Dr. Seungwon is with us for the next 3 months
Mhm.
to write up the Dart mixed response paper. So Liam, you know the project. Why don't you have Taeyong and Seungwon? You can tell them separately because about the project and how to write up a paper on it. The all the there's a I think are you making the poster? There's a mixed response uh
Yeah,
abstract.
probably. The abstract, I believe, was submitted to ASCO.
Mm. Oh, we're still waiting for the results.
No, the result. I think the results are out.
Oh, do you have the list of who got in?
So that one, I, let me double check, but I feel like Megan submitted it.
Hmm. Okay. So Liam and Sally, let's make a list of from our lab what abstract got in and who's the project lead and everything. Let's uh come up with a summary. And then Liam, for the DART mixed response project, uh I think you've been the project lead for it, but I want Seong, because she did this, and then Dr. Seungwon to be involved in actually writing the manuscript together. So you can
Sure.
work with them, make sure they have all the materials. And the concept is same. How would mixed responder behave in the setting of dual immunotherapy in rare tumors? And the data is amazing. So yeah, we treated about 800 patients, accrued over 1,000 sites in the US. So
Actually, we're still waiting on the ASCO results.
okay. But I think I was the first author for the mixed response.
Yeah.
Yeah.
Yes. So we have that list, and we were the ones who submitted it. So yeah, you're right.
So yeah, Seong and Dr. Suwon, I think that will be a nice follow-up project after this one. Okay, anything else, Seong?
Yeah, I have two more posters to show.
Okay.
So this one is the CIP with Picture Health. The title is AI powered radiomics
I
model.
don't see it. You have to share it.
Sorry. Mm,
Okay.
here. Yes. So the
Predict-
title is AI powered radiomics model predicts immune checkpoint and inhibitor related pneumonitis in advanced NSCLC patients.
Hmm. Okay. Okay.
And I'll probably get rid of this one. Same one. And for the results, I've requested Picture Health last week for the ROC curve, but I haven't received it yet. But I'll double check, follow up on them and have the graph on the feedback next week. So
Okay. So 10 patients. Hmm. Okay. Go you go down to conclusion. Yeah. Okay. This looks fine.
oh, nice. So that one was for the CIP. And the
So-
last one,
So
yeah.
just the project wise, what is the long-term plan? Seong or Liam, like, are we collecting more patient for this Picture Health project, or are we not?
So for Picture Health, we've finished our initial study with 159 patients.
Hmm.
So we're just gonna finish that up. We just have a couple more abstracts we're gonna submit with them with this data set to the World Lung. And then afterwards, it's going to be kind of phase 2 of our collaboration, and it'll be a completely new data set. And we're going to be working off of the EDW that we're working on. So, we are doing the first screening and the second screening, and we're annotating all the clinical data. And once we finish that, we're going to request the DICOM files and the path slides so we can do both the radiomics and pathomics on the EDW data set, which will be all Northwestern. And per Picture Health's interest, as well as ours, we're going to prioritize the neoadjuvant cohort that we screen out or filter from the EDW cohort. So that's going to take a couple more months for us to get actionable data, but that's the plan for now.
What about the metastatic cases? Are we, updating those lists?
Yeah, so we're gonna annotate all of the lung cancer patients in the EDW. So after second screening, I anticipate we're going to have about 1,000 patients for that we have data for. And the neoadjuvant cohort probably will be around like 50,
Okay.
just according to very rough estimates.
EDW, do we have access to the Lake Forest Northwestern?
That's a good question.
Because they see quite a lot of lung cancers up there. They're on their same system, so. I don't know who handles EDW. I know we got that with the help of Dr. Iso Kim, but
Mhm.
maybe post that question. How do we get access to the Lake Forest or like other NM? Because now it's under the same epic. It should be related. I don't know if there's a way to extract the treating physician's name. You can verify there are, Dean Saras, and there are Lake Forest physicians, oncologists. So, it would be much better if we can have access to those, but maybe do some investigation, Liam, and
Yes, I'll look into it.
same, and if it's not, what are the ways to make that happen?
Sure.
So we have to make decision. So Taeyong, with what you have, is that worth publishing? Versus, do we need to go to phase 2, get more patients, and then publish? Did Picture Health say anything about what they want to do?
From what I know, we expanded the number of patients regarding the abstract sent out for ASCO. And this is AACR, so ASCO abstract has a bigger population. So, and I think that was the entire segmentations and works that was done while I was there. And I think that was the end work for the first batch that we have. So I can double check, but
Yeah.
if that's the case for so if we have that cohort ready for ASCO, I think it'll be a good wrap up there and continue on with what Dr. Liam was saying and check with Picture Health.
Okay. Show me your third poster. Are you able to come, Taeyong, or?
I was keep communicating with Dr. Liam, but I still don't have the TS2019 released for me now, which means I wasn't able to get the visa interview either. So it would be hard for me to start working from April 1st. I was trying to talk with Dr. Liam more about this regarding coming to AACR and getting the visa works again.
Hmm. Okay. Yeah, we're just few weeks away. So keep working. You know, visa is out of our control. Yeah, but certainly hope you could come
Yes.
sooner than later. Okay.
Yeah.
Yeah, show
Yeah.
me the poster.
Yeah, so the last one. So this one is the ClickSeg one. The title is Accelerated and Precise Tumor Segmentation in NSCLC, Comparative Analysis of Automated ClickSeg, a name that Picture Health gave, and manual annotation for radiomics. So it's basically comparing the manual segmentations vs the auto segmentation that Picture Health has made. I also requested the data of the automated click 6 seconds for the manual annotation segmentation works that we have so that I could draw box plot last week, but I haven't received it from Picture Health yet, but I'll follow up on this and I'm planning to get a plot here.
Okay. Now you use the toxicity table here?
Oh, no. Toxicity. Which one are you referring to?
Table 1.
Oh, yes. This was just, I would say it's not, I was also thinking what table I should put in here, but this was, from what I know, like in the same, like a sub analysis that we did while we were doing the CIP. So it was the same cohort with the same patients, so I just put CIP.
Yeah,
for
so you
now.
cannot do this. Because pneumonitis is not the focus here. So you would anybody used for this project, how many
Mhm.
patients did you actually look at for each group?
So this involved total of 105 and the lesion was 168. But the times that was recorded wasn't, so these 168 wasn't all recorded, but only some.
Okay, but you have to say maybe 168, but you randomly selected, each
Yes.
group. Um, and the
I think-
ones that were actually, segmented, their patient characteristic, in total, like not by pneumonitis, it's like all lumped up in one group. That's the
Oh
table.
yeah. So would this work? This was pneumonitis, but this was just the clinical characteristics of the whole group.
Yeah, you can say whole group,
Okay. So
but
not
take
this.
out the CIP. It
Yeah.
has to be one column.
Mhm.
So it will be combined. You understand, right? What I mean, right? The two columns are gone. CIP, non-CIP.
Oh, these two.
Combined.
Oh,
That has to be
okay.
combined.
Ah, I get it.
Yeah, and the table 2 has to be gone, because that's pneumonitis.
Yeah.
I mean, in the manuscript, I don't know how many were randomly selected. It has to be that number, not 105, because that 105 is the mother population,
Right.
but that's not the group that you actually worked on.
Mm-hmm.
But if you don't have that information, it's okay to use this for now for the poster purpose.
Yes, I think from what I know, this was kind of like a pilot study,
Yeah.
so very few number of the lesions were measured, so it'll be best
So
for to have the whole group.
yeah, so ask them how many lesions were used in two different
Yes.
groups.
Mhm.
And then these average, there has to be like a graph, bar graph difference, and with
Right.
the p-value, and you need a better description of that.
Mhm.
So I know Picture Health, they have medical writer. So this
Mhm.
is what I would propose to them. Number one, immune toxicity. So this is for Seong and Liam to follow up. For immune toxicity, there's only 10 patients who belong to the immune checkpoint inhibitor induced pneumonitis. It's
Mhm.
gonna be super difficult to come up with any validation model. There's a training model and validation model. To come up with it, you need larger sample size. So,
Mhm.
but Picture Health seems to have way to kind of work around it by doing, multiple bootstrapping and things like that. Kind of like statistical, uh, um, it's called statistical exercise or something.
Mhm.
So what I'm saying is immune tox could be a little challenging, but if they are open to it, why not? Number one. Number two, response prediction. I think it's doable to do testing and validation for modeling. Uh, and it's not a big cohort. So picture health, AI model, response prediction, toxicity prediction, and in the method, say we used the autoseg, and it was pretty efficient. So combine all of this into one manuscript. Uh, and Seong and Liam, you can work on sort of giving a framework as to what we want, what we're planning, and then propose to them, do you have a medical writer that can work with us to write a manuscript? It's best to have larger number of patients, but at the same time, we don't want to sit on what we have presented.
Mhm.
So the writing manuscript would be based on the ASCO number, uh, the largest number of patients. Uh, the Liam talked about phase 2, where EDW project is gonna take time. So I don't want to sit on it. Rather, I would publish what we have. Publication is the currency in academia. We need to publish, not sit on a poster. So I think we need to work with Picture Health to get the paper out. If Picture Health is not gonna write it, Seong, you're in charge. Write the paper. But it's a paper, one paper that encompasses everything. Because
Okay.
I don't think these should be, to have one of these to be each paper is too small.
Right.
But we did this with biodesics before. If they have a medical writer, it's going to save our time immensely. So if they can provide medical writer service, then let's do it. And let's start conversation this week. We have already the poster, we have already analysis done. We just have to start writing it. So Liam and Taeyong, you'll be in charge of actual manuscript writing project. Okay,
Yes.
okay. And then Seong, once you join, we have many students or MDs, so you're welcome to work with anyone who's interested in learning radiomics, write the paper together.
Mhm.
Everyone's invited, and reach out to Seong if you want to work with Seong, but she's the project lead. Okay, good. Anything else?
No, that's it. Thank you.
All right, good. Keep up the good work. These are really good posters. Really hope you can come, but you know,
Yeah, me too.
yeah, but it is what it is, and but
Yeah.
yeah, but I think it's just a matter of time. You will be here in a month or two time frame, right?
Mhm.
And yeah, be able to start. Okay, good.
Thank you.
Thank you. All right, let's go to Richard. Update from you.
Yeah, hey Dr. Chae. I have a couple of kind of quicker updates. So I heard back from BMJ Open about the Nivo ipilimumab trial for
Mm.
ACC salivary gland
Yeah.
cancer. So I try to update them and update them on the situation, but they still weren't interested in the journal. They took like 2 weeks to reply, but they
Mm.
said that because of the patient enrollment not meeting the quota that was initially set, um and like the limitations with the conclusions that could be drawn, they weren't very uh willing to accept the paper, so they rejected it.
Mm.
So I was thinking I could submit to Cancer next. Um, it's a Wiley journal. I think it's free. Is that correct?
Mhm.
To publish there? Okay.
Yeah.
Um, yeah. So I was going to do that today if that's fine.
Yeah.
Okay. And then another thing is I realized that we didn't send the manuscript to BMS. We sent the abstract to them, and they like
Really? Okay. I didn't
um
know. Yeah.
should I do that?
Yeah. I think that's
Okay.
yeah,
We'll
we
do
should
that, and then once they get some edits, I'll submit to Cancer. Then,
yeah. So
yeah,
CC me and Liam
yeah.
for that communication.
Uh-huh.
Yeah, cancer's a good journal. Cancer. So for all of you, there's two models, open journal and closed journal. Open you can download, but the author has to pay something between 2,000 to 4,000 for for any publication, and that's a lot, and I think it's a wrong model. Like, why would you pay to publish your own paper? And I don't make you guys to pay. I pay it out of my own pocket. But the closed journal model is when you subscribe to a journal, right? Most libraries would, pay subscription fee to each journal. Uh, so the journals make money through that and download fees for each journal. So the authors don't have to pay anything. NEJM, JAMA, they're all, the traditional models. But now a lot of journals are making money from authors. So the more papers you publish, you become poor and poor. Yeah. So people are trying to fight this, and I love the preprint model. So Richard, why don't you preprint it? Because I don't know how long it's gonna take. So
Right.
Liam, you can give him like the preprint information. Just get it out there in the world. So the whole point we're publishing something is so that people in other part of the world know, wow, there was actual trial done in adenosystic, and this is what Nivo AP show to the world what. And if it takes so long to get the result out there, the people will not benefit from that knowledge. Preprint makes it happen. And then, the people who, if it's a popular topic, people will start downloading it.
Mhm.
You know the preprint from Dr. Juhi Park?
Oh, yeah.
Yeah, that was like the top 10 or something, right?
Yeah.
Yeah, it's a topic that people want to know.
Okay. Okay.
Yeah.
Should I do it before or after BMS like makes any changes? Like I could do it today, or I could just email BMS today and then after they get back.
Yeah. After BMS gets back, then do the preprint.
Okay.
For preprint, you don't need BMS permission.
Oh, okay.
But at least get their edits, reflected.
Mhm.
And say that we're submitting to cancer, but we're also, you can tell them we're also gonna do a preprint to there's two different journals, right? One is medRxV,
Yeah.
the other one is SSRN.
Mhm.
See which one is better. And for Lancet papers, they have their own as preprints.
Hmm.
So that might be good too. But that's only relevant if you're submitting to the Lancet series journals.
Okay.
Anyway, yeah, just that's not gonna take. That's just uploading your PDF file. Like it's.
Yeah.
And then they will let you know if this is suitable for their platform in a day or two. So that's really easy. But
Yeah.
yeah, try cancer.
Yeah.
Okay.
Cancer, email BMS, preprint. Okay. And then the two other trials that I was kind of like considering, so or like that you brought up with me. I was working with Dean with them, the Nevo veliparib and the
What
Nevo
happened to Dean? Is he reachable?
um he wasn't I so I think he's done with the lab.
I saw him.
Oh.
Like Sally, do you know Dean?
Yeah. I know Dean. But I think he's not coming to the lab anymore. So he handed off all his projects to Richard.
Okay.
Yeah. So Richard has all the updates.
Okay.
Yeah, so I don't know if I can do both. I'm close to submission for the Nevo veliparib.
Hmm.
I don't know, there's been a lot of stuff going on, but I
Yeah.
can get that probably that one's doable. The Nevo metformin, I was hoping to hand off if anyone is open and willing to take that one on.
Yeah. I think Rachel would be good. So
Okay.
Rachel can get the Nevo metformin paper.
Okay.
Yeah, and then carry on. Why don't guys do a separate Zoom meeting or something or meet up, and you can kind of explain the project and what's been done, and Rachel can kind of work from there.
Yeah, I can go to the lab and just pop by. I'll like message you or something.
Yeah,
Yeah.
yeah.
Okay. But yeah, that's just a quick update for those.
Good. All right, let's get yeah. You're getting close, but it's not easy. Yeah, but I'm sure you'll get there very soon. Good.
Thank you.
Oh
Yeah.
yeah, and then the translational piece we tried and we couldn't get it done, right? Yeah, the
Mhm.
trans.
Yeah. They don't
Right.
have the samples. They lost the
Yeah. Y- Um, the Nevo metformin or the Nevo veliparib, I don't know. I mean, those are patients treated mainly here, right? Northwestern. So, we can get slides and try to look, you know have scan it and send to Lunid and kind of do some translational work with it. I guess it depends on the number of you know hmm. I think it may be worth it to do that together because both are using Nevo. One is veliparib, one is metformin, but we might be able to link some response or survival with the H&E slide findings. What do you think, Richard?
Yeah, so the Nevo veliparib one is pretty close. I mean, I don't really know about the molecular characteristics of like how veliparib could, interfere with like, like tumor infiltrating lymphocytes. I'm not sure exactly how that could play out, but the rest of the manuscript is pretty much done. Dean got interest from JITC about the paper.
Mm.
You know what, I guess what I could do is like I could email them and just like refresh their memory and say like, hey, like, are you still interested? We were also thinking about doing an analysis with like a TIL analysis. Like, would that be of interest to you? I could ask and see if that would be of interest, or do you think that that's just something that we should do on our own?
How about just, coming next 1 week period, let's do a survey. Meaning like, how many patients do we actually have slides here?
Gotcha. Okay.
Yeah, so do that with Rachel. So Rachel, you can do that for the nivo metformin patients, and you can do that for the nivo veliparib patients. It's not many, and then I just worry that the journal will do the same thing because I think both trials. Well, first of all, did both trials end because of funding, or is this one different?
Um, these might be different. I don't think I think they were phase one. It's been a while since I looked at the.
Yeah. So hopefully not. But but what I want, so there's patient list, and then you know who to get the patient identifiers if you don't have it. The CTO, the data managers would have it. The same person who gave you the patient identifier for the ACC paper. So if we can get the patient list, we can go to Epic and say, look at uh the relevant H&E slides. Are they here in Northwestern? So the criteria is whenever they started Nevo, what is the most recent biopsy that has the H&E slide? So if you can go to the chart, document the date of biopsy, and there's a block number or something. Just record those. There are not many patients, like what, 15 patients or some.
Yeah, 20 or
Yeah,
so.
yeah, it's like somewhere between 10, 20. So you'll quickly get that list for both trials, and let's next lab meeting we can kind of decide is this, if it's numbers 5 in every, it's we're not going to pursue it. We're not going to be able to show any response. And then it would be good to so the other thing is, there's not many responders. So if the responders have no slide and it's all non-responders, what are we gonna show? You know what I mean? If
Yeah,
if
yeah.
if there's something that we can find, then I think it's worthwhile doing it. So, if we can document any kind of outcome like progression-free survival or response, something, and then the presence of sample, in both trials, work on that preliminary and make that decision whether we want to proceed.
Okay.
I think it's 50-50 chance that we might, do it. So let's work on that first and decide. But yeah, the Library can be submitted. But let's have an answer to this and then submit that one.
Yeah, sounds good.
Okay.
Great. I'll work with Rachel on that.
All right. Thanks, Richard. Let's go to Sally.
Okay. So, EDW, I have updates. So first screening, we came really far. We started from 1439 and now we're at 892. So I think we made a really good progress. I think we can keep going in this pace. Since the undergrads, they're on their vacation this week or break, spring break. There is not much update for first screening, but one reminder, Dr. Chae, I think we need to give them or you need to give them grades.
All right, come to my office. We'll do it together.
Yeah, we'll do that today. And then second screening, so we started off with 145, but we're gonna get more patients from the first screening. But as of now, I think we're gonna start with 145 patients, and then, but this week, yeah, 40 patients were screened, and so now we have around 100 left. So those are the updates for EDW. Any questions? Second.
No.
And then, so, oh yeah, for anyone else who like don't know about this spreadsheet, we're gonna keep updating this spreadsheet for all the projects and then week by weekly. So if you can update about your project in here, it'll be great. But yeah, so for VC projects, so I talked with Eugene yesterday and he said he's really busy, like he has like another research he's like taking a gap year to do research right now. So I think he was really busy with that this week. So he said he will submit the preprint by end of this week. So we'll have that done by next meeting. And then Emma's paper, so they said they're still editing the paper, like they noticed some error in the end. So they're still in that process. So I think, yeah, Eileen said she'll submit it by March 26th. So like right before her spring break ends. So that's still in progress. And then VC4 project where so we submitted the preprint revision. And so that's been submitted, but we're still working on the manuscript that we're gonna submit to not TCR but Helion. Yeah, but I'm gonna have a meeting with Dr. Uni today, and so for that I've been actually studying R Studio. So if anyone's really good at R Studio, please let me know.
Why do you need R for this paper?
Oh, we're trying to create like graphs, like ROC curves and yeah, those graphs. I could use like other platforms, but I've been learning R, so I wanted to use R to create them. So I'm still figuring it out right now, but I think we could definitely get it done by next week, all the edits. But we're gonna have a meeting tonight to talk about it.
So put a good prompt in ChatGPT. It will spit
So
out the code.
yeah, it's weird because so I did ask last night, but their code it didn't work because it's hard to explain. Like for I guess it works. I don't know. Like I tried with ChatGPT's codes, but it didn't work. Like to simply put. So I think I need to figure out some other coding, like debugging the code.
Yeah,
Yeah.
Dr. Gi Woo or Jian Lee might be a good resource.
Yeah. So, okay, I'll reach out to them or even Dr. Eugene, because I know she's really good at R. But yeah, that's it for VC4 project. So it's still moving along, all 4 projects.
What about Emma?
Oh, Emma's project is the one that Eileen said she'll submit it by
Okay.
March 26th.
Okay.
Yeah. And then other than that, I've been yeah, just learning R, and then also I've been helping Dr. Yu Jung with SEER, so I've been also learning year program. And yeah, we're still building the red cap, so we'll give you updates once we have things finalized.
Okay.
And then I'll give a presentation on hyperprogression at the end of everyone's updates.
Okay.
Yeah.
Sounds good. Okay, Dr. Soin.
Okay, so last week I've been updating the EDW, and also I submitted the updated version of the abstract for the Tempest IMA. So that was done last week, and we're still waiting for the response from them. And I'll give a short presentation on the Tracer X project, as you mentioned last week, at the end of everyone's update as well.
Okay. So you're working on the proposal?
Yeah, I'll look into that as well.
Yeah, and then if you have questions, just come to me and ask those questions. We can
Okay,
troubleshoot
okay.
together.
Mhm.
Okay, Dr. Changwoo.
Yeah, from your comment on last week, I searched some papers about immune checkpoint inhibitor induced toxicities, especially for pneumonitis. And while reading the papers, I found out the Cancer Imaging Archive. So I was curious that if we could use this imaging data for strengthening the radio mix project.
What is your question?
So while I was reading the papers, I found out that there are database like SEER, and it was involving the cancer imaging.
It has cancer, like a CT scan?
I guess so. So let me show this
Yeah, you can share this,
slide.
the screen.
This is the website I found. They have open imaging data for many cancer. I, I read about this from this paper. I was curious that if there is any project that is going on in this lab involving this database.
No, we haven't used this data. But does it have clinical outcome and what drug they were used?
I couldn't go far to find out if they have that kind of data.
Yeah, so it looks like they have CT scan and then H&E slide here. The histopathology is H&E slide. Segmentation and existing. Can you click the browse collection? Left upper, yeah, let's see what data. So colorectal 49 patients. All these slides, clinic, and then supporting data, clinical, prostate, clinical, profile. Okay, maybe what you can do, Dr. Chung, you can focus on lung cancer cohorts and it says clinical. Let's see what kind of clinical outcomes are there. And are there outcomes such as immunotherapy drugs used or immune side effects? See if any of the data contains that. And just start with the lung cohort first. And let me know, okay? Good.
Other than that, I'm still waiting for Dr. Isu's contact.
You don't have Dr. Izu's contact?
I mean, I gave her my number and still waiting for
So Liam,
assignments.
Liam, why don't you have Dr. Chong text Dr. Iser?
Yeah. So I gave Dr. Iso Dr. Chong's number, but I guess she hasn't been able to get around to it yet.
Yeah, just email and text again. I think she's very busy. Yeah. What else, Dr. Chong? I know you've been interested in toxicity, so have you talked, did I tell you to get in touch with Carolyn?
Yes.
Did you meet her?
I met her when I shadowed you last week, but I couldn't talk about the research project.
Yeah, so why don't you meet her in person or through Zoom? And
Okay.
just say Dr. Chae want me to work with you to publish the the toxicity review paper. I know she's almost done, but she can get some help from you and you can learn from her review. There's referencing, making tables, figures, and adding some more paragraphs. I do think there may be more work remaining. So work with her to write the immune tox review paper with her. Don't just passively sit and wait for them to get back to you. You have to reach out to them until they get back. Okay.
I see.
And you can go to her office. Sally knows where Carolyn's office is. You could just go and meet her and sit down and talk to her. She's very reachable.
Okay.
So Sally, you can give Carolyn's cell phone number as well as the email. Okay. Anything else? Any other questions or updates, Chong?
No, that was it.
Okay. All right. Keep up the good work. Go to Dr. Rachel.
Yeah. For the last week, I did EDW and about the radiomics, which I have to get this hands off from Monica. But yesterday morning, I got the message from Monica. She got sick, so we postponed the meeting to tomorrow 9:30 a.m. So I still am waiting for the for getting handoff of radio mix, and otherwise about Seer. Honestly, I'm still working on more detail about Seer, and I'm thinking about how to use it and use it more effectively.
Mhm.
Now, that Sally and I work together and figure out how to set the table and extract the data I need from the software by adjusting various variable. It seems like I still need some time, but almost there. I hope so. And then let me show you my screen. Oh, oh. I just want to share my screen to show you guys what I did for the last week, and then the data from this year. And yeah, that's a brief, just let you guys know what I did briefly.
Okay.
This one is the paper I read since about 10 days ago, 2 weeks ago, and then I also mentioned about this in the last lab meeting. So I am focused on Seer. As Dr. Chen mentioned at the last lab meeting, I put the stage and I put some factors to analyze this. And stage raise and extrapulmonary versus long limited cancer and survival rate over a 5-year interval. And then Dr. Chae, you also mentioned of the progression and lipidic versus non-lipidic, but in SEER, they are not, they don't have about these progression and lipidic or versus non-lipidic, so I cannot do about it. And my next goal is I still have to figure out how to put the p-value, because the data shows me confident interval already is 95%, but I want to put the p-value and then getting the meaningful data. So I have to figure out and simulate every graph in the paper with R or theta and then get the graph. And next one is, you also mentioned about the IMA with only distant matrices versus IMA with limit in long, but I don't think there are some I don't think I can put the variable whether only distance or lay distance in here, but I will try. And the next one is I also will compare Tempest data and SEER data, as you mentioned, and I will put TMN stage and compare the survival rate and prepare work long to submit abstract. Yeah. This one is I put the stage to I put the stage as a factor, and then this one is lung adenocarcinoma. I divide it into non-mucinous and mucinous, and then I put the stage localized, regional, and distance. So I calculate the survival rate, and then these one co-specific these column is the survival rate. But this table is not good to look at it. So I also make the graph. And then as we expected, localized stage shows better survival rate. And then about the distant stage, it shows decreased survival rate as the time goes on. And at the mucinous adenocarcinoma of the lung is more dominant. And then I also
Go back to the graph.
mhm.
So So cause-specific survival rate is, so first of all, you have to I don't know why for non-mucinous you have 120 there. Both, I think it has to be 100 as the max, and then you line them together. If you have both different graphs. Because you could argue, you could make a 3 different graphs,
Mm.
cause specific, and maximize the difference between the non-mucinous, mucinous in one graph, how they are different. Same thing, cause specific, survival, regional, so regional disease.
Mm.
Then you have 2 graphs in mucinous versus non-mucinous. So you can rearrange the graph like that. But anyway, the lesson is mucinous distant does really well, worse.
Yeah.
Versus the low regional is worse as well.
Yeah.
Everything is worse. So yeah, that's
So
it's
you mean
it's
I have to make it together as grade?
yeah, but don't put 6 graphs, all together. Just put 2 in one graph,
Oh,
3.
oh, makes sense. Actually, I also make the bar graph at the next page. It is I compared to, like, as you mentioned about the localized stage, survival rate of the 12 month is blue one is the non-mucinous, and orange color is mucinous type. So at the localized stage, it shows little differences between each other, but at the distant stage, it shows dominant differences between each other. Is it? Is it? Yeah.
I would do just the Kaplan-Meier curve. Because it's too many landmarks.
Oh,
Yeah. Yeah. So just do the Kaplan-Meier curve. You don't have to do it at each point. So when you say
oh,
cause-specific survival, is the cause cancer?
yes.
So I would do cancer-specific survival then. Then we don't say cause-specific in cancer literature.
Oh, got it.
Okay.
And this one is I put the race as a factor, variable factor, and divide into white people and black and other and unknown. And I also calculate the survival rate, and then in this graph, yeah, it's too many, but it um it it shows little differences between each other. For example, survival rate of the 60 months at the type of non-mucinous adenocarcinoma, compared to white, black, and white, black patients. Other this group, green color, other group is more. It shows more better survival rate, and then at the mucinous adenocarcinoma, I realized that the black people shows the better survival rate. For me, it
I
was
would first show like a pie chart how the each group consists of. If they're small number, then you're very skewed, or there's a prone for random error.
Oh,
And then this one same, I would make that into four different Kaplan-Meier curves. And if
oh,
the other doesn't make sense, we don't have to add other. We can just do three. Oh, well, we have all race, white, black. So other has, okay.
yeah.
You can put other, but I wouldn't put all race here because just the three different graphs.
Oh, delete the or races.
Okay.
Got it. And this one is about the metastasis. And I also make the graph. And then maybe I thought that about 20 at the extrapulmonary cancer, because the data is not enough or too small, and then SEER didn't show me the result of the analysis. So at the extrapulmonary cancer, it just shows about 25% of the survival rate to survive for 12 months. But at the lung limited cancer, although the survival rate is decreased, but yeah, it shows survival rate like this. This one is by year of diagnosis with the 5-year interval. Yeah, graph is too many, right? Sorry about that.
Okay.
Overall, non-mucinous adenocarcinoma of the lung, this one survival rate is better than mucinous adenocarcinoma. And then survival rate is increased. Overall, the survival rate is increased, I think. Yeah. Yeah. I just want to show you
Yeah,
what I did.
yeah, go back. So 2016 to 2020 non-mucinous, do we have data?
Yeah, SEER didn't show me the data for these periods, so yeah, I couldn't make the graph. I don't know why. I will figure out.
Oh,
Yeah.
but you have mucinous.
Mm-hmm.
So I guess the survival is improving with better diagnostic, better treatment options. And so I think just showing that is good, but in terms of mucinous, we're not, I don't know if we're making that progress. Maybe we are, because 24 to 36 good, but 48 is still not optimal. So you can, where these can be in supplemental figures, it's
Oh.
fine. But again, I would make that into all Kaplan-Meier curves.
Mhm.
Okay, so go back to the previous figure.
This
Go,
one?
no, 11. So when we say lung limited, because we're thinking about DREAM patients,
Mm.
of course, stage 1, 2, 3 is all lung limited.
Oh.
If you combine them, you're comparing apples to oranges. Extrapulmonary is by definition stage 4. So we want to know lung limited stage 3 or 4 at least. Ideally just stage 4 only. Stage 4 only lung limited versus extrapulmonary present stage 4. How do they, behave differently? Survival is different. Same thing, you should show that as a Kaplan-Meier curve difference. Okay, so work on that.
Thank you.
Good. So get to know the data, see what you can do with it, and you know the good questions, so see what you can get out of it. My concern is that there is no systemic therapy treated cancer. And it's the treatment method, I don't think it's annotated there. It's just the stage 1, 2, 3, 4 and all these things, so yeah, it's limited, but still we can ask these questions. Okay,
Okay.
keep
Thank
up
you.
the good work.
Thank you.
Yeah. Okay. Sue, do you have any updates on anything you've done for the last week? Dr. Sue?
Hello.
Yeah, any updates on what what you've been doing?
I've been doing some EDW work. That was the most of it, and reading some journals about after our after my observership at the clinic. I was reading about ADCs. Yeah, that was pretty much it. And I just got an email from Liam. I will get in touch with Dr. Seyoung and yeah, get into the mixed response with dual checkpoint inhibitors. And sorry that I had to drop in the middle.
It's okay. Yeah, I thought that would be a good project that you can kind of learn from and publish together.
Yes, yes, I saw the abstract and yeah, I really like it. I am very excited for it.
Hmm.
Thank you.
You're welcome. So when you do clinical research, how do you best annotate outcome? You know, when you read a paper, what does it mean to say responder, non-responder? You know, what's the measurement? What are you measuring?
I saw you
Mhm.
you said the tumor like grow or decrease by 5 millimeters. I was wondering like
Mhm.
is that the diameter or
It's the largest diameter.
I
Uh,
see, I see, I see.
yeah. So every criteria is different. RECIST is different. WHO criteria is different. Even mixed response papers are using different criteria. So you have to first study how
Got
to
it.
best annotate, describe tumor response, and go from there.
I
And
see.
there's a debate about response and progression-free survival and overall survival. There's a disconnect. Some might have very inferior response rate, but some will have very long survival rate. So where is that disconnect coming from? What is the biology to explain it? What is the biology to explain mixed response? It's definitely a tumor heterogeneity in terms of immune microenvironment, also in terms of genetic heterogeneity. So how do you interpret that? All these things should be in the discussion of the paper you're writing. Okay.
Yes.
Okay. So it will be a really good clinical project because, you know, drug development, a drug can be killed if you have a wrong outcome measurement.
I see.
So let's say there's a TKI and you treat GIST, gastrointestinal stromal tumor, GIST. If you give that TKI, the tumor gets larger. Most of the tumor gets larger. What does that mean? The tumor goes into a liquid necrosis. When it undergoes necrosis, the tumor always becomes larger. This is the biology of GIST, okay? But if you don't take that into account, you're gonna say, well, this is a failed trial. You'll kill the drug that's working well. You understand? So
Very interesting. Yeah, yeah.
you have to know by each tumor what is the best response. In lymphoma, we always use PET scan. We have to know the FDG avidity difference. We don't go by just measuring the size, okay? So understanding that is critical. And if you're not a doctor in the clinical field, you have no idea. You know about the chemical of a drug and how it works in mice. You have no idea how to clinically interpret response or the best outcome. So that's why I need a clinician scientist who understands this paradigm. So yeah, so keep reading. There's plenty of good papers talking about what is the best clinical outcome
Mhm.
In terms of drug development. So you can keep reading and yeah, learn that aspect. Okay, Liam, update from you.
So I don't have too much to go over, excuse me, over Zoom right now. I have a lot of stuff I can go over with you in person
Yeah.
in the afternoon, but there was just two clinical questions or needs that I just wanted to bring to your attention. So I'm just going to share my screen. So two cases here regarding Andrea Roth. There's an email thread regarding her basically adjuvant treatment. So Dr. Mazabid is also included in the email, Mohammed Hazabid. This is what he said, and they're just waiting for your input.
Yeah, so we need to send so I think she was squamous, right? Andrea Roth.
Think so.
I don't think she had any target. So work with Bridget to send all the post transplant labs. So I don't know if she's ready for chemo. Do you have any update on her condition? Is she doing well? Still on oxygen? Do we have any
I
idea?
do not.
So let's go and see her right after this. So we
Okay.
have to see her if she's candidate for. So find out where she is. Look at her condition, read her notes. We'll go and see her to see. And maybe in the meantime, Sally can pull up her path report and show it to in the Epic and share the screen. Okay. And we'll look at because I know she is cohort A or C.
We'll have to look it up.
Yeah. So
Okay, so the next question while Sally pulls up the chart is, this is from Gardens. Garden emailed us about two patients who had actionable or who had clinical trials that they would be eligible for. And this is for patient BL. There's a study here at Northwestern, and he just wanted to let us know that there was this clinical trial available for this patient and wanted to see how you wanted to proceed.
doesn't to evaluate pharmacokinetics of inavolisib. with solid tumors and in combination with endocrine targeted therapies in breast cancer. So do we know who this patient is?
Yes, it's patient PL. Or do you want the name?
Yeah.
So it is Lafontaine Bershabeth.
Oh, that's sad. She just went to hospice. I think she might have died. So, but why is it BL?
So her last name is Lafontaine. That's what starts with an L. Her first name is
Oh,
Bersabeth.
okay. Yeah, so not relevant because she cannot get it.
Okay.
So for you guys, PIK3CA is a good target, but we don't really have a good drug in lung cancer. Okay,
Okay, yeah, that's it for me, at least to be discussed over Zoom.
so Sally, can you pull it up?
Presentation?
No. Andrea Roth. Oh, you didn't hear it? You Andrea Roth path results.
I was in bathroom, sorry. Yeah, I can.
So in the meantime, Liam, can you see if she's listed consented for cohort A? So Sally, you can share the screen when you find the path report of Andrea Roth, our dream patient.
Staff report.
Yeah, so March 7th. Yeah, surgical path report. Yeah, so let's see. Okay, part A, left lung. Mucinous adeno. Oh, she's mucinous adeno. I thought she was squamous. Okay. PD-L1 0%. The right lung, PD-L1 0%. I'll go down. So left lung pneumonectomy. So invasive mucinous involving left upper lobe. 12.3 is huge cancer. Chemotherapy, killed 30%. So 70% viable tumor. 4 lymph node margins were negative. Okay, good. The left pleura was positive. Carcinoma. That's bad. 7R. 0.6 centimeter, 1 was positive. Chemotherapy killed 30% of tumor. And the right lung margins negative, left upper lobe, middle lobe. And then right, okay. And then, okay. So right pneumonectomy, okay. 6 centimeter. Um, 70% viable. Local lymph nodes were in the all negative. Final tumor stage will be rendered upon completion of the molecular studies. Okay, go to the molecular studies. Close that. Yeah. Oh, it's all in process. Okay, Liam, so we're gonna tell the team to get Tempest, Gardent. So it's still stage 4 cancer because there's a pleural involvement. This is kind of the nightmare that we were all dreading. We wanted everything come out clean, but the pleural biopsy showed cancer. I don't know where that is. So I think doing a radiation to the pleural area that was positive should be the recommendation. So Tempest, Gardent, Signatera, Gardent, Reveal, and Cell Search. DTC needs to be ordered. And because of 7R lymph node, it's pathologic N2. But because of the pleural, it's pathology M1. Not sure if it's A. Pleural involvement makes it stage 4. It's T4 because it's bilateral tumor in different lobes. Bilateralness makes it, M1A as well. So M1A is separate tumor nodule in contralateral lobe with pleural or pericardial nodule or malignant pleural effusion. So M1A. M1B is in a different organ. M1C is in multiple different organs, like outside lung. But it's still M1A, based on the bilateral nodule, as well as the pleural nodule. So M1A makes it what about the T staging? T4 is greater than 7 centimeter tumor, so that makes it T4. Separate nodule or in ipsilateral, different lobe. but its contralateral makes it M1A. So it's T4 based on size, so it's still stage 4A, which is T4, PM2, PM1A. This is important for your red cap, okay? Make sure what I said is reflected. So she's cohort A, right, Liam? Yeah. So we gave her chemo, which is a gemcitabine. And she has pleural mets. So I think she needs radiation to pleura. I don't know where uh let's share the screen. I will pull up her PET scan for you guys. I need to drive. In the meantime, Liam, read her chart. See if she's doing well, recovering, or if she's not doing well, septic or. Okay, let me share your screen. Okay, do you see this epic?
Yes, we see it.
Okay. Oh, her last pet was October. Oh, what is it? Interpretation of outside pet. Dated December. They don't mention plural activity. Let's see. So if it was seen by pet, we could have biopsied it, but nothing showed there. So in retrospect. All right, so this was December. So maybe here, maybe. Or maybe here. So left side, so this is the largest tumor. This was measured 12.3 centimeter, this tumor. And probably this tumor is measuring 6 centimeter. And everything else, these are small nodules. And maybe these are invading lymph node. Maybe here. So it's N2, but So the right plural, that was the right plural space that was positive. Oh, no, 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 it's left plural, right? Sally, it was
Yeah,
the left plural. So it's kind of abutting it here. Hmm. There's something here too. So number one, I think we have to radiate here. And because of N2, we took it out, but it's new long. And let's see. Okay. So she had the first surgery, 2021, adjuvant CISPEM. And then she got stage 4 disease in like a year. Carbo Alimta Pembro. Got diverticulitis. Got pemetrexed. Clinical trial. Another clinical trial. She has KRAS mutation. G12D. D is not so helpful. And then she got the Gemzar by us. So we can't do any more immunotherapy. We can do chemo. She already got cisplatin carbo. She got Alimta twice. So I don't know if it's actually going to help her by giving chemo, because mucinous is usually not responsive. So she never got Taxol. So she's 70-year-old. Either carbo or cisplatin Taxol times 4 can be given as an adjuvant. Or Abraxane can be given for better tolerability. And depending on her kidney function. Well, look at her WBC count. Hemoglobin is 8.3. Bilirubin direct is 2. I wonder why is her liver numbers are tanking. She might not be in a good condition. So if she's not in a good condition to get chemo, then She can get radiation to N2 and chest wall, pleura, and get chemo. Hmm. I know she just had surgery, but I would rescan her everything. So this was ordered and not done. So I would get MRI brain. I would get PET CT. I would get CT cap. Before I start chemo, I need to know if her disease has spread outside her lung. Get all the biomarkers done. And see if her condition is anywhere close to starting chemotherapy. So thoracic surgery, Shayna said she's got lung on the 7th. Is that right? Room air, AFib, febrile. This LFT could be some of the immune suppressants. Only thing they're missing is onc. I think they're waiting for my input. Weaned off shock requiring persistence, weaned off, extubated to transfer to the floor. Lipid stop supplemental, but did not pass calorie count. Okay. Okay. Well, it's something we expected can happen. So yeah, Dr. Wu, and welcome. This is a case where we cohort A, we did transplant. Explant says there's a pleural involvement. So I'm thinking radiation and adjuvant chemo, but adjuvant chemo may not work. But I think we need to give it. So yeah. So yeah, we'll go and talk to the patient after this. Okay, let's take a 5-minute break and we'll get update from Dr. Wongi and do the 2 other presentations. Okay. Okay, I'm back. Can we get update from Dr. Wu? I
Just for
can't
a
hear
second,
you.
please.
Oh yeah, now I hear you.
So, pre-transplant malignancy is now in preprint. So it's in Medrix, I think. Yeah, it's preprint from I think 2 days ago. And the review process in JHLT seems finished. So the status is changed to required review completed. So it's been about a month. So I expect them to give us major revision, but I think there's a high probability that it can be rejected. So we need to think of the second journals to submit.
Do you have a
So
suggestion?
because this is actually I don't know exactly which one would be better,
Hmm.
but I think there is American Journal of Transplantation journal, so I think we can try that. If then rejected, maybe we can try two other transplantation journals. So yeah, because there are not many lung transplant focused journals other than JHLT. So yeah, that is
Okay,
my thing,
let's do it then.
ideas.
That's fine.
uh, can you hear me? Oh, I can't.
What are you trying to share on different screen?
Can you hear me?
Yeah,
Uh,
yeah.
yeah, and the second part, the graft failure, post-transplant malignancy. Hasong is reviewing the manuscript. Yeah, as soon as she finishes it, we will submit to JAMA or others as you recommended. So that is
Okay.
our thinking. And as soon as she finishes the abstract, I will send the abstract to the owners to get their opinions. Yeah. For metastasectomy, I sent abstract to JAMA Oncology, Lancet Oncology, JTO, also lung cancer, and they all said they won't be interested in our topic. So I think the Annals of Surgical Oncology might be interested in our topic, and so I sent our abstract again to them, and I'm waiting for their response. Whether they give us response or not, I think we can submit it to the Annals of Surgical Oncology. That would be a good journal. Yeah. So that is our plan. And for Tempest project, so Dr. Son Kim finished the abstract. We sent our abstract to Tempest, and I think we, we will just proceed on writing manuscript based on Tempest data.
Yeah.
It's not a kind of a thing that we wanted about IMA focused. But I think when we had a meeting 2 weeks ago, it feels like they want to proceed with this project, and maybe we need to write another proposal to focus on the IMA. So I think it will be the kind of next topic, but I'm not sure how long it will take.
So this one is what is the title?
This one is titled between IMA and non-IMA. So yeah, that will be the project.
Yeah, but what did you say about the separate project? What do you mean?
Separate project will be focusing about IMA only. So we will analyze about 700 IMA patients, and we find some possible prognostic factors for them. So it can be B-cell infiltration differences, or it can be some gene expression differences. So
So just within all IMA, right?
yeah.
Yeah, okay. Yeah, that makes sense. But this is just IMA versus non-IMA. What is the difference, right? Yeah.
Yeah. So I will proceed this with Sign Kim, and we will finish writing manuscript, I think, within 3 weeks.
Okay.
Yeah, that will be
Yeah.
my goal. And for metastasectomy, I think Aranus and Brandon has done their part. I think now, as you recommended, I will just proceed on writing manuscript. So
Yeah.
I structured it. I will finish in 2 weeks, and I will share that.
Mm-hmm.
So.
Sounds good.
And we will submit this abstract also for the world long if it is rejected in ASCO.
Oh, ASCO result came out?
ASCO will, I mean, in 10 days, I think they will send the result.
Oh, but how do you know it was rejected?
I think it seems it may not be kind of their topic because they
yeah,
more focused on the other medical and biomarker topics. So we will prepare also for the world long as well. As soon as we get the result, I think we can submit these to world long also.
Sounds good.
Yeah, this is my update. Yeah, so we will send. I will update with the manuscript from next week, and yeah.
Sounds good. Sounds good. Yeah, I think we're getting there. Yeah. Good. Yeah, also you can mentor Rachel as she explores the Sears data. Um, okay. Hmm. And also because Rachel's gonna be here for a while, I think it would be good for her to learn the whole transplant data, the international and the UNOS. So because Haesung's gone, I think Rachel can, while she's exploring the SEER data set, maybe Dr. Wu, you can teach her what's in the transplant data set, and
Okay.
probably you can learn as well. So because we can, still we can ask good questions with the data set. Before we were using R and random forest to, so it's, with all the variables there inside, the question was, can we predict survival? Can we predict infection? Can we predict rejection? Like the AI modeling of the transplant field. I don't think it has been done. And today, there's Dr. Chung Jong Chul. Have you heard do you know him? Dr. Chung Jong Chul? And he is a postdoc or sabbatical or visiting scholar in transplant immunology lab in University of Chicago. And he reached out to me to see if we can work together. So he's seriously studying immunology, transplant immunology. So maybe we can get some input from him and kind of hear what he's studying. So Dr. Liam, so is it a kind of remote meeting today? I thought he was coming in person, but
I think he's coming in person.
really?
Yeah. Does
Hmm.
it say it's a?
It has a Zoom link,
Yeah, no, I think he said he's coming in person.
but why is there a link? He said he's coming.
I think that was just my mistake.
Oh, okay. Oh, okay. But Dr. Wong, you're not able to come today. You can come and meet him if you come. It's 1 o'clock, right? 1 o'clock is the meeting.
Yes.
Yeah. But yeah, because you're involved in transplant. Okay, but I can meet him today. But Dr. Wangi, you're welcome to join if you are available. It's 1 o'clock in my office, so it's like an hour meeting.
Dr. Chae,
Uh,
he's in lab right now.
he's here?
Yeah.
Oh, I didn't know. Oh, you're in lab. Okay, I didn't know you're in lab.
Actually, my speaker is not working. I'm just listening to your doors.
Okay. Okay. Okay, yeah, you can definitely join for the 1 o'clock meeting. And we can maybe have lunch together or something. Okay, what else? That's it, Dr. Wongi? Okay. Good. So we have time for, let's start with Dr. Soin's presentation.
Okay, so let me share my screen first. Do I have about 10 minutes? Okay, I'll try to make it quick. So this was a paper that I read. Hang on. I'm sorry. Okay, so this paper is about the TRACER-X study that actually focused on genetic analysis and to actually map the lung cancer evolution and its impact on clinical outcomes. And so as you all know, lung cancer is the leading cause of cancer-related mortality worldwide. And this study actually prospectively enrolled 421 early stage treatment-naive NSCLC patients. And it used multi-region sequencing. So it actually incorporated 1644 tumor regions to analyze, to actually map the phylogeny of lung cancer evolution. So as I said, unlike the previous studies, it used larger cohort, which means it had greater statistical power. And by analyzing multi-region, you could kind of guess, I guess, infer the phylogeny, like the shown in the picture. And this figure actually is a whole patient clinical course that was categorized into two histological types. And as you can see here, each line actually represents one patient and marked by different clinical factors like types of therapy and recurrence and stage, and as well as all the information about the intratumor heterogeneity. So before I go on to other figures, the paper actually used 3 evolutionary metrics to measure the intratumor heterogeneity. So one is SCNA, which is somatic cell number alteration. And that was actually previously used, but the newer prognostic factor was this subclonal whole genome doubling and recent subclonal expansion. So this was one of the figures in the paper. So so as you can see here, they included 3 evolutionary metrics to actually see the prognostic change and effect.
I'll go back.
Mhm.
So relative, the TNM is the best, prognostic indicator. And you have pack year, then histology.
I'm sorry.
Histology wise, I don't know, does better. Squamous is a little bit worse, although it's not significant. If you get adjuvant chemotherapy, then you are a little bit protected. But this is a little bit flawed in the sense that you do require adjuvant in a higher stage. So that's a bias there. And here, recent subclonal expansion is the only thing that was high-low. Yeah. So that's really interesting because the other ones are widely used as well. So okay.
Yeah, so in this I'll show the figures in the next slide, but in terms of the disease-free survival, all 3 had statistically significant association, but only the recent subclonal expansion had additional prognostic value. So that was interesting. So as you can see, like from the top left figure, the SCNA had statistically significant association with DFS, disease-free survival, and as well as the subclonal whole genome doubling. And interestingly, the truncal whole genome doubling had no association. So you have this special subclonal whole genome doubling you can use as a prognostic factor. And the recent clonal expansion shown in the far down right. And this SCNA, which is widely used, as Dr. Chae mentioned, had additional association. It was related with extra thoracic recurrence within the 1 year after surgery. So specific patterns of recurrence was actually associated with this number of alterations.
So oh yeah. So yeah, read that sentence.
This actually highlights the need to consider not only the number of subclonal mutations, but also the clonal architecture specific to each tumor region when exploring the association between genomic ITH and prognosis. And like my question here was like, how practical would that be, like to actually implement this finding to each patient? Like this is so labor taking results. So that was labor.
So how do you know clonal architecture and the number of subclonal mutations? I mean, we do it by counting clones number. And then but how do you know what's trunk, what's subclonal? And in a single biopsy, that's a problem, right?
Right.
It's autopsy, right? Yeah.
So I think it's the concept of multi-region sequencing that is required to actually figure out which mutations is truncal and subclonal, and that's actually assumption. So there are more studies to be followed, I guess.
Yeah.
And
so here's your thought. In the future, now what do we do if we have a liver met in the lung cancer? We do liver biopsy. Okay. We don't do lung biopsy ever. Okay. But in the future, I can see with robot of a size of a fly can go in, do a painless biopsy and come out, You can get multiple safe biopsy. So a human being can undergo multiple site biopsy in the future with the help of technology and produce phylogenetic tree at diagnosis, which is going to help predict find more targets, find the clonal architecture, and really predict what's going to happen. So this is a wild, uh, I guess it's almost, well, let me tell you this. When I started my job, when I was sending blood DNA testing, no, everyone was saying, "What? That's crazy. Why are you, why are you doing that?" But now a lot of people do it simultaneously, and I think that's more ethical now because you find more target. But even with blood biopsy, you're not going to be able to find good target. So I see a future where like there's a liver met, there's a bone met. As long as we have a better technology to get a safer biopsy, I think it will come up because like a blood biopsy is not gonna be able to get everything. It can get more sensitive, but there's a limit. So I think we will do something like autopsy, very similar to autopsy, even at first diagnosis. I think that's a future that's coming. But we're not there yet. We're gonna meet with a lot of resistance if we do that. So what do? Blood and tissue, one needle tissue at the same time. Anyway, proceed.
Okay, so the primary endpoint of this study was to study the relationship between genomic ITH and prognosis, and this is a summary. So SCNA ITH was previously recognized indicator. It had a significant association with shorter DFS, but it was only when they considered patients with recurrent disease. So it had kind of subset of patients that only showed significance. And these two newly identified indicators, subclonal GD and recent subclonal expansion, was linked with a shorter disease-free survival. And next, they calculated the DNDS ratio, which measures gene level selection in point mutations. So on the left, it's from the adenocarcinoma cohort, and they measure these mutations in genes that are frequently mutated in cancer. So the blue dot actually represents the truncal selection, and the red dot is subclonal selection favored. So if you look at the on the bottom, the TP53 KRAS is commonly known as the tumor initiating genes, but so you assume that truncal it's mutated in more cancers than other genes. So it's actually it actually showed truncal selection. So it was kind of confusing at first, but if you say truncal, it means mutations at the trunk of the phylogenetic tree. So it's the mutations that took place early in the cancer evolution. And the subclonal favored genes are the mutations that happened late in the cancer evolution. So that's how they kind of came up with this evolution timeline using this genetic mutation analysis. So that's this figure.
So
what was it?
I'm trying to understand, let's for instance, the middle figure, the x-axis is the truncal N, and what did you say N and S stand for?
It's the just non-synonymous synonymous ratio, but I'm not like 100% getting this method, but it's a ratio that measures the amount of mutations.
Gene level selection and point mutations. Gene level selection. So non-synonymous is the functional mutations, the functional versus non-functional mutation in truncal. And then you have oh, I see, I see, I see.
So like depending on the tumor types, some set of genes were mutated early in the cancer evolution. For example, KRAS is actually truncal for adenocarcinoma, whereas in squamous cell carcinoma, it's actually on the up red with a red purple dot. It's not as truncal as in adenocarcinoma. So that's how they came up, I guess, with the phylogenetic tree.
Yeah, it's really interesting.
Mhm.
Interesting. Okay, and the truncal events, explain the right side graph.
So it's so this graph actually shows the dependency between the mutations. For
Mhm.
example, like if you have SBS 13 on the truncal events on the very top, you're not gonna have like SBS 92 truncal mutation because it's mutually exclusive. Whereas SBS 13 and the very bottom SBS 2, do you see my cursor? No.
No.
It has a purple box on the very left corner downside.
Yeah.
So SBS 13 mutation tends to co-occur with SBS 2 mutations. That's kind of paired. So this paper, like on the paper, is that like some TP50, if you have truncal, I'll show you here. So if you have TP53 mutation as a truncal mutation, it actually increases likelihood that TERK AMP and SBS2, SBS 13, and whole genomic doubling events increases. So one mutation actually prefers other mutations. It pushes the direction of the subclonal mutation.
So increase the likelihood is so each subclonal events increase the likelihood of the upper.
No, actually the other way. Truncal event, because truncal takes place earlier than subclonal. So if you have TP53 at the base, you are likely to have TERK mutation.
Oh, now
when the subclonal expansion takes
okay.
place.
So the gray is the direction of the effect, and then just the
Right.
likelihood is the
Right.
colored.
Mhm.
I see. Okay. It makes it really confusing.
Yeah.
I understood. Yeah.
So that was an extensive work, I think. And I think it's really marks the beginning of understanding cancer evolution and timeline. So this is another figure, but I'll be quick. This SBS4 and SBS 92 are the two mutational signatures that have been linked to tobacco smoke. And like, if you are exposed to more tobacco, more PEG years, you're likely to get more SBS4 mutations. But they figured out that in adenocarcinoma, SBS4 is likely to happen, whereas in squamous cell, it's the SBS 92 mutation signature that are significantly correlated. So they're suggesting maybe you can use those two mutation signatures as surrogate markers for amount of smoking mediated mutagenesis in both lung cancers, in each lung cancers. So
So truncal, wait, go back. So truncal SBS assigned mutations. And what is the x-axis?
Peg years.
Oh, pack years. Okay,
Mm-hmm.
as the pack years goes on, there's SBS 4 correlates pretty well.
Weak.
It's weak.
I know.
Okay. I'm not impressed. It's still weak. Okay.
Mhm. Okay, so this is another aspect that they studied. So some of some of the heavy smokers didn't carry this SBS4 mutation
Mhm.
and yet had adenocarcinoma. So they looked into this all the genetic mutations and realized that those smoker with no SBS4 actually carried mutations that are frequently found in non-smoker.
Mm.
So they're suggesting, there are there is a two-step model as to how the tobacco induces mutagenesis. It has tumor initiation part and the promotion part. So they're saying maybe there is an alternative pathway to tumor initiation in tobacco induced mutagenesis.
Mm.
So
And there are maybe mutation induced like EGFR, but they
Mhm.
happen to smoke.
Mhm.
So we don't know which one's first, but this
Right.
is good. This is good. Yeah.
Yeah. So that's this. And conclusion. So this study again mapped this natural history of each tumor from early stage treatment naive NSCLC patients. And those evolutionary metrics I mentioned in the beginning, the three of them can be used together to predict the likelihood and timing and future relapse of lung cancer. And understanding the subclonal dynamics can actually lead to more accurate prognosis, and maybe we can apply that to personalized treatments. And another great aspect of this study is that it provided extensively sampled tumor data set with clinical and genomic metadata for future studies. And so we can understand better about this tumor and maybe improve cancer outcomes. Thank you.
Okay. Can you go back to your let's see. The slide number, can you do slide number 2?
2.
3. Okay, so there's another paper that goes through individual, like actual phylogenetic tree.
Mm-hmm.
So in that Nature issue where I think Charlie Swanton published like many papers in that issue. Anyway, maybe you can read the one with phylogenetic tree analysis and present that paper next week. Now, and then next slide, please. Next one. Yeah. So this would be more technical. And you can do that with Dr. Chongwo as well, if you guys can divide and conquer. So this is all mathematical. How do you calculate SCNA ITH? How do you calculate, subclonal WGD? How do you calculate the expansion score? I'm sure in the method section there they referenced They
Right.
don't necessarily explain everything in their paper, but they reference how they did it. But understanding that is gonna really help you. Uh, like so there's a raw sequencing data. And this is I'm so this is your next homework. You can kind of give presentation on these three methods and how to calculate that, and you can do it with Dr. Chong as well. But this is important because for the whole genome project proposal you're working on, you're gonna be proposing to use these methods. Because we're gonna do whole genome, not just exome. And it's important for you to understand, what are we measuring? And the simple ITH is really, there's the simple method, and then you can use STAS and the review paper. And if you don't know, Dr. Liam will give you the paper. It's the one STAS and myself wrote in a review paper about the ITH. And we talk about the simple methods of calculating ITH. But we don't go through the second, third ones because there's not much whole genome database. And I'm surprised that do you think that 142 patients, the 400 patients, how many go to
421.
421? Do you think most of them underwent whole genome sequencing? I'm a little surprised. I thought that was exome sequencing, but you can kind of look into it, like how many actually got. And then the other thing is, you can repeat this yourself. This is publicly funded. I think it was probably a UK fund or something.
Right. It's okay.
Yeah, but most publicly funded research, you can download everything like Dr. Changwo showed us. You have to upload it, the file. So, like a pilot project would be, yes, they've shown this and that, but we can look into our own question. Like this ITH, does that correlate with, something else? I mean, I'm sure they looked at every possible variables, but we can come up with a different question. So the question is, look into possibility of downloading it or accessing the cloud where they have the data, and then learn. If you do, then there's R code you can use. ChatGPT. There's gonna be codes to do it. It's a shared code. You can download it, and using R or Python, you can make the code and do it yourself. That will be the best exercise. If you can do it yourself, and Stas can be your resource because he's really good in doing all these ITH analysis, assessing clonality. So this is a nice statistical exercise for you to learn. And you don't have to learn everything, but you have to get the concept. Is this the right way? And at least able to describe that in your proposal to the genomic site or Enocross. Yeah. Okay, so work on those, and yeah, we'll discuss more at next meeting. Okay, good, but this is how you learn. Good job. Yeah. All right, Sally, you're on next.
Okay. So this is a presentation on hyperprogression. I don't know if you guys remember, but I did give a presentation a few weeks ago. But this will be more of like a comprehensive presentation. So I will go over just few like important points from the last presentation, and then kind of introduce you guys into a new paper that was published in this lab. So just a quick background once again, hyperprogression is a tumor response in which the existing underlying tumor grows rapidly after initiating treatment with an immune checkpoint inhibitor. So for immune checkpoint inhibitor, these are the potential outcomes. As we know, here in the red, progressive disease, it's where tumor growth becomes expensive on imaging, and it grows rapidly after getting immunotherapy. So this is just a case study of a female in her 60s with renal cell carcinoma. So the tumor showed significant progression with nivolumab. A baseline scan before treatment with nivolumab demonstrated an infiltrated retroperitoneal mass involving her right kidney and renal vessels. And then 6 weeks later, they did this scanning again, and then but this was after nivolumab therapy, and it demonstrated an increase in the retroperitoneal mass, and then some of new hepatic metastases. And then C, a follow-up scan done 10 weeks after initiation of nivolumab, and it demonstrated an extensive increase in size of the mass and a significant increase in size and numbers of new hepatic metastases, confirming disease progression. So this is just one of the case studies that was reported.
So that's a renal cell?
Yeah, yes, renal cell carcinoma.
Okay, and just a single agent nivo?
Yes.
Okay. Do you know if it was a first line or second line, third line?
I can look that up and then tell
Yeah.
you guys after.
So in your slide,
Uh-huh.
make sure you
Yeah.
write renal cell carcinoma and nivolumab.
Okay.
It doesn't say anywhere here.
Yeah, I wanted to decrease the amount of text, but I think those are very good points to mention. So I will add that. Okay. Yeah, I will add that after. Should I continue?
Yeah.
Okay. Yeah, so as we have seen, radiological criteria for objective progressions are based on an evaluation of therapeutic efficacy from treatment onset, but they're not sufficient to distinguish between naturally aggressive disease course and a therapy-related change in the tumor growth kinetics. So several different metrics have been proposed to describe the magnitude of change in the tumor growth rate before and after immunotherapy in patients experiencing hyperprogressive disease. Also, while incidences range from 0 in renal cell carcinoma to 29% in head and neck squamous cell carcinoma, it's very difficult.
Why did you say renal is 0? You just show us a case of renal.
Yeah, in the paper, in the background it says 0%, but I don't know. I don't exactly know where that background information came from, but it did mention that it was 0 in renal cell carcinoma. But yes, I did just show you guys on paper. Yeah. So maybe this was not updated.
Okay.
Yeah. So, but the point is that it's difficult to determine whether these varying estimates reflect differential tumor intrinsic behavior or whether it arises from differences across current definition of hyperprogressive disease. So multiple studies have shown the impact of hyperprogression disease on like PFS and OS, as well as change in rate of tumor progression. But I wanted to point out these 3 specific studies that are the papers that our lab published used, specifically their methods and their definitions of hyperprogressive disease. So first is Chae et al. So it was a retrospective study of 218 patients enrolled in phase 1 clinical trials. And the authors used tumor growth rate before ICI treatment and compared it with tumor growth rate while on ICI therapy to better understand the relationship between PGR and OS outcomes. So this study defined hyperprogressive disease as a twofold or more increase in PGR from pre-ICI to on ICI scans. And it was evaluated by RECIST criteria. And then the second study for et al. So it was a retrospective study once again. It included 406 patients with non-small cell lung cancers. Their definition was minimum of 2 CT scans before ICI and 1 CT scan during ICI, and they calculated the tumor growth rate by using the % increase in tumor volume. And then lastly, Sada Bouzid et al. It was a study of 34 patients with recurrent or metastatic head and neck small cell squamous cell carcinoma treated with ICI, and they used a definition of ratio of greater than or equal to 2 of rate of tumor growth pre-ICI compared with on ICI to define hyperprogression disease. So these are the main studies that we will talk about here. So the main purpose of this presentation is to evaluate the current evidence on HPD across variable definitions and to investigate whether the incidence varies by the type of definition or tumor type. So this was the paper that I presented last week. It was published by Arnie and the rest of our team here in Dr. Chae's lab. So just pointing out a few things. So yeah,
Is this it's
preprint.
Accepted, right?
It was only in preprints that this was
so
the
it
only
is accepted. It's in processing right now.
Okay. But okay. But it's medRxiv. Okay. Yeah, go ahead.
Okay. So yeah, so these are the 3 definitions that I just mentioned by Chae, Ferreira, and Saida. Continuing on. So these were some discussion points. So incorporating new measurable lesions in treatment response assessment would help with better assessing hyperprogression disease. And then next discussion point is that prevalence of each definition after immunotherapy in non-small cell lung cancer patients should be further investigated. And then combining chemo and immuno may be effective in preventing HPD. And then further investigation is needed to the heterogeneous results based on the different parameters of tumor burden. So yeah, so based on that, so this is our next paper done by Dr. Minjung Kim et al. With the
rest this is actually published online now?
Yes.
Can you send that to the link to our lab chat room?
I will send it. It was accepted January 2nd this year, so pretty recent. I will send it in the group chat. So yeah, the paper was on incidence of immunotherapy-related hyperprogressive disease across HPD definitions and cancer types in observational studies. It was a systemic review and meta-analysis. So yeah, so they once again used these 3 definitions by these 3 authors based on their papers and their definitions here. So they called it definition A, B, C. And these are some exclusion criteria if you were interested. But I can also share this PowerPoint with you guys so you guys can have it later. And then they did statistical analysis. Primary outcome was HPD incidence. and then meta-analysis, statistical heterogeneity, and then potential source of heterogeneity. They looked at these through statistical analysis. So this meta-analysis included 34 studies from 12 countries. So they in total reported 558 cases of HPD among 4,117 patients across 7 single tumor types and mixed tumor types. So the overall estimated incidence of HPD was 12.4%, and ranged from 0% to 36.73%, with evidence for heterogeneity that was statistically significant. So HPD incidence was compared across different definitions, both qualitatively and quantitatively. The graphical representation here, based on the threshold of change in tumor growth kinetics for each definition, it revealed differences. So first of all, as the threshold for definitions A and B, so green and orange color, so based on a ratio where both the numerator and denominator must be, value greater than 0. So these two definitions can only describe HPD in patients who experience an increase in tumor burden during both the pre-immunotherapy and post periods. But on the other side, definition C, it's based on the difference in the tumor growth rate between 2 time intervals. So it can capture HPD patients who experience a decrease in tumor burden during the washout period and an increase in the tumor burden after starting immunotherapy. So area D right here, it represents like a subset of patients who are evaluated as having HPD according to definition A, but not C. So the range of post-immunotherapy tumor burden changes that characterizes this area suggests that these patients are more likely to meet the criteria of progression based on appearance of new lesions and not based on an increase in tumor size that is greater than 20%. So this is the forest plot of HPD incidence and the 95% interval across 3 different definitions, A, B, C. So definition C had lowest estimated incidence of 10.5%, and then it was 12.219% in definition A, and 18.03% in definition B. But univariable analysis showed that the type of definition did not have a trend for a significance as a moderator for HPD incidence in this study. So in this figure, so the estimated incidence of HPD was also obtained for each tumor type subgroup. So as you see, advanced gastric cancer, hepatocellular carcinoma, mixed or other non-small cell lung cancer, etc. So the estimate was highest for advanced gastric cancer and HCC, so hepatocellular carcinoma, and non-small cell lung cancer, and mixed or other type groups right here. So RCC, renal cell carcinoma had the lowest estimates of 2.16%. So univariable analysis showed tumor histology as a significant moderator for hyperprogressive disease incidence, with estimated incidence of HPD significantly higher in advanced gastric cancer, non-small cell lung cancer, hepatocellular carcinoma, and mixed when compared to the renal cell carcinoma.
How many slides do you have left?
I'm almost done. This is the last figure.
Oh, okay.
Yeah, so this is the table, just after adjusting for definitions used, the risk of developing HPD was higher in AGC, just repeating what I mentioned before. And then after adjusting for tumor type, definition B reported higher incidences of HPD than definition C. So that was one of their significant points. So some discussion points. So this meta-analysis was consistent with previous findings that there is statistically significant heterogeneity in the HPD incidence. So this suggests that there may be a subset of patients that are less or more likely to experience hyperprogressive disease. So it's really crucial to identify specific indication that could make distinction between the patients who are more likely to experience from those patients who are not likely to experience HPD. So specifically, the odds of experiencing HPD was significantly higher in AGC, HCC, non-small cell lung cancer, and then mixed or other type when compared to RCC, renal carcinoma, and then HPD incidence was also higher for definition B compared to definition C. So it could lead to, it introduces uncertainty in the estimation of true HPD incidence. So it could lead to general overestimation or underestimation of HPD incidence. So it's really important to continuously investigate in differences in incidence between all the definition types. And these are some future direction. Differences in incidence across tumor types and definitions remains unclear, and then explore how the immune landscape of each tumor type contributes to differential responses. And lastly, how it's altered by the introduction of immunotherapeutic agents in the tumor microenvironments. So that is it. Thank you.
Great. Thank you for the great presentation. So my suggestion is, so I said like make it like a TED Talk, meaning make it like a one theme. This looks like a two different journal club. You know, what you went through the introduction, results, discussion. So in a presentation, tell me about hyperprogression. And then you're gonna have to talk about why it is important. You're gonna have to talk about what are the definitions. You're gonna have to talk about, what did the other studies show? You're gonna have to talk about, is there a risk factor? You're gonna have to talk about, in the real world, what happened to our own patients. So you are in a way incorporating everything in one theme, not as a journal club going over the different sections of the paper. So try to reorganize it so that it is a topic, and then you talk about it in your own logical steps. And every paper will be cited accordingly, not as a journal club format, but as a topic presentation format. I'm just training you. But so it's more of a reorganizing, and we talked about Sarabuzid and all that. I would present the actual, the three definitions. I would go through the graph of the actual paper and then actual incidents and actual prognostic implication of those definitions from the original papers. At least original paper, the figures and the numbers. So it will be make it so that it's all encompassing presentation. Don't follow the journal club format. Okay, but everything you presented is good. I feel like you understood the topic very well, but just reformat it, and you can just bring the reformat. I can give you the update. Yeah, so you don't necessarily have to represent it, but reformat it, and I'll give you input. Okay, we'll have to end here. Thank you, everybody.